Hello everyone, this is N. Kavita, working as Assistant Professor in Department of Electronics and Instrumentation Engineering, Hindustan College of Engineering and Technology. The subject which we are going to see today is Applied VLSI Design, and the specific topic is Fundamentals of FPGA Design. These are the content which we are going to focus in this presentation. We are about to see what are all the introduction to FPGA, what is the need of FPGA, what are all the elements available in FPGA, its advantage, disadvantage, along with its application. In addition to that, we are supposed to see what are all the vendors available for FPGA and FPGA design tools. In today's digital world, all the digital electronic systems are basically classified into three kinds of devices. The classifications are majorly based on memory, microprocessor, and logic devices. What comes about memory is it is actually used to store your random information. The microprocessor is used to perform a specific task by executing a software instructions. And finally, a logic device. So wherever we go in any timing and control operation or for displaying any kind of digital data, almost every other functions, it is required to perform a logic device. It provides specific functions, device to device interfacing, data communication, and signal processing. Without all these three basic kinds of devices, it is highly impossible to create a digital electronic system. So what is this FPGA? You might have heard it already, a field programmable gate array. The word itself indicates the program are done in an array fashion. These FPGAs are a specific programmable logic devices where I can able to program different functions in a short period of time. This FPGA has been arrived in 1984 for an alternate purpose of PLDs and ASICs. It is a programmable logic device that supports for implementation of a large logic circuits. Why do we need FPGA? What does the word FPGA or integrated circuit means? The world of integrated circuits is definitely composed of full custom ASIC design, semi-custom ASIC design, user programmable logic devices, and FPGA. Without the combination of these five, it is highly impossible to create a IC world. In full custom ASICs, what we design is the designs are all completely customized and the user can make the programs on his own choice. Whereas in semi custom design, a specific set of libraries are already declared and we are able to program only a part of the device. User programmable or a kind of devices where I can make a complete programming of a digital circuit. We have got programmable logic devices, and in turn, this PLD is classified into programmable array logic, programmable logic array, and finally FPGA, which is nothing but field programmable gate array. What are all the elements available for FPGA? There are basically three different elements which is composed inside the FPGA. The first block is configurable logic block. In short, it is acronym as CLB, and second is configurable input output blocks. You might have heard this IOB, which is acronym of input output blocks. And third layer is nothing but the programmable interconnects. Actually, this programmable interconnects are like a network of vertical and horizontal lines, which is used for the purpose of interconnecting the configurable logical blocks and field programmable gate array. Here comes. What is the difference between this ASIC and FPGA? ASIC is nothing but application specific integrated circuit. FPGA is field programmable gate array. The major difference between these two devices are ASIC provides a very high performance, low power and low cost in high volumes. Whereas in case of FPGA, it is actually used for the low development cost. It is reprogrammable. This is the major advantage of using this FPGA. Here comes one by one the elements of the FPGA. The first element is nothing but configurable logic block. This block is actually a random access memory, or I call them as a basic logic cell. For executing any digital circuit, it is supposed to configure a logic. Without a logic, it is highly impossible for a digital circuit to take place. What does the CLB consist of? This CLB consists of a register, which in short I can call them as memory. It contains multiplexers, which is used for selecting the data, and a combinatorial functions, which is nothing but to perform a combination of specific logics. And this CLB contains an array of specific sets, which is embedded with horizontal and vertical channels. All these channels are routed together to interconnect the CLB. Next is the architecture of single CLB. So what is present inside the single CLB? You could see this single specific configurable logic block will contain a lookup table. The main purpose of this lookup table is it is actually used to inbuild the inputs. So all the inputs are provided to the lookup table. From the lookup table, the signals are provided for the global level and the inputs are directed towards the memory. This memory will contain a few bits of information. For activating this specific CLB block, I require a clock signal and this clock is being triggered. Once these inputs are passing inside the CLB and if it is required, a feedback is provided from the memory again to the lookup table. So this is all about a configurable logic blocks architecture. It contains lookup table, memory, a clock trigger, and finally the outputs are obtained globally or locally according to the programs, and the output is obtained at the final part. What is this configurable input output logic blocks? So this CLBs are surrounded by a specific programmable input output pins, which is nothing but an arrangement of transistors together. This transistors is supposed to provide the input and output to the specific FPGA. What is a programmable interconnects? So these are the unprogrammed interconnection resources on the chip, which means that I'm not able to program these interconnects. These are like a connecting routes where I can be using a fuse links to connect the inputs and outputs inside my FPGA. This programmable highly interconnect matrix is available inside the programmable interconnects and it is specifically used for the purpose of communication. Next, how does it arrange? Actually, the programmable interconnects are arranged in a row column architecture fashion where you can observe there are different rows and we have got different columns and there will be a vertical track and there will be a horizontal routing channel and segmented tracks to pass my information. So inside all my programmable interconnects, I could find the logics which are arranged in horizontal as well as in the vertical fashion, or in turn I call them as row to column architecture. What is the major advantage of using this FPGA? So the design cycle is significantly reduced by using this high gate density. It produces a low cost design where it doesn't require any masking tool. The risk is very low and it is highly flexible. Actually, in today's digital world, these FPGAs are replacing the small scale integrated chips and medium scale integrated chips. So these are all the basic advantage of FPGA. What is the major drawback or disadvantage of FPGA is actually the circuit delay will be depending upon the performance of the design. If your digital circuit is keep on increasing, according to the design, the circuit delay will be increased. The second limitation is that the mapping of a logic design inside this FPGA architecture will require a specific CAD tool or any sophisticated design implementation is required to make a complete digital design. So, what are all the vendors of this FPGA? Actually, this FPGA is not supposed to go with all vendors. Many vendors are available in market, but the most demanded, or I can say the specific manufacturers of this FPGA are Xilinx, Altra, and Actel. We know that for programming any kind of FPGA, we use specific tools followed by the applications of FPGA. This FPGA are used for complex algorithms, application specific hardwares, for implementing any digital signal processing circuits, and for designing any low cost customized digital circuit, I can go for FPGA. So what are all the tools available for designing this FPGA? The major tools which is available in market for designing FPGA are Verilog and VHDL. As it is already known, these two are the basic programming languages, or I call them as hardware descriptional languages, which are used for designing this specific FPGA. And this Verilog is actually similar to a C program where you can able to give the input outputs and you can make a program for implementing any kind of digital circuits. Whereas the second part is called VHDL. It is a very high speed integrated circuit hardware description language. Actually, this is a kind of set of rules that is available, and it is a separate content which we can see further presentations where we will be having three different categories like entity, library declaration, and architecture to make or to construct a complete digital design programs. So where this FPGA is used is we can able to program this specific digital circuit and it is implemented using this FPGA. Thank you for your patience.